To prepare for the ACT, let's look at question 21. Question 21 states, in the figure below, points R, S, T, and U lie on the circle centered at O. Which of the following does not appear in the figure? Within a circle, we know that all radii are congruent, meaning that line segment RO, line segment SO, line segment OT, and line segment OU are all going to be congruent segments. We also know that if we have two sides that are congruent, then the base angles also have to be congruent, meaning that angle OUT is going to be congruent to angle OTU. If I know that my angle UOT is 60 degrees, that means that I know for my other angles, I'm going to have 180, which is my total degrees within a triangle, is equal to 60 degrees plus, and I'm just going to call one of these angles here x, so I'm going to say 2x. I subtract over 60, I have 120 degrees is equal to 2x, and I get that each of those angles are going to be 60 degrees. So I know that all three of these angles are going to be congruent. Now I can go ahead and start looking at my answer choices to see which one of these does not appear in the following figure. So the first thing says an acute triangle. Well, since I see a 60-degree angle here, I know that there is an acute triangle. Then it says an equilateral triangle. If I know that all the angles are congruent, that also means that all the sides of my figure have to be congruent as well. So I know that we do have an equilateral triangle. The next option I have is an isosceles triangle, and I can see that both of these two triangles within the circle are isosceles triangles, so that's not going to be the correct answer. Then I have a right triangle. I can see that ROS has a right angle in it, so that's not going to be the correct answer. So the last thing that we are left with is a scalene triangle. And again, if we look at our two figures, we can see that we have two sides that are congruent on both of our triangles, meaning that yes, a scalene triangle does not appear in the figure above. So that would be our answer. For more ACT practice, visit numworks.com.